Hello, class. Welcome to my physics lab presentation. For this lab presentation agenda, we will take a deeper look into Experiment 3, Force and Motion, Experiment 4, Combining Forces, and lastly, Experiment 5, Force, Mass, and Acceleration. Let's start off by taking a look at Experiment 3. The main objectives for Lab 3 are to develop a reliable method for measuring forces, learn how to use a force probe and measure the force using the probe, and finally, exploring the relationship between an object and the forces that are applied to that object. For the data collection in Experiment 3, we used the rubber bands, the force probe, the carts, the motion detector, and of course the ramps to take a look at the relationship between force, velocity, and acceleration. While performing Experiment 3, we did face some challenges. To get started, the first activity where we took the rubber bands to graph the relationship between the force and the number of rubber bands, we actually didn't have all of the same rubber bands. They were not all identical. So when we made our initial graph, we didn't have this nice straight line depicted on the graph above. We actually had to redo the experiment again to make sure that we got this nice straight line on the graph. Let's get into some details about what we saw in Experiment 3. So the graphs pictured here are from Activity 2.1 and Activity 2.2, and they are demonstrating the relationship between velocity, acceleration, and force based upon our setup. So for the top graph, Activity 2.1, that was when we pushed the cart away from the motion detector, stopped it, and then quickly pushed it back towards the motion detector. So we were looking to see if the acceleration would decrease or increase and how the force would be affected based upon the acceleration. So we looked that they were between the force and the acceleration, and based off of Newton's second law, we know that acceleration and force are proportionally related. So as the acceleration increases or decreases, the force also will increase or decrease. Now, if we take a look at Activity 2.2, that's when we released the cart with a constant force using a hanging mass. For our hanging mass, we chose one that was 10 grams. Now, if we look at the results, it shows that the force remains constant. However, the acceleration is kind of all over the place. And we know from the previous activity that force and acceleration are proportionally related. So what went wrong? There could have been interference with the motion detector if we were too close to it when we initially started the experiment. And we also didn't catch the cart in time, so it hit the end of the ramp, which could have given us some faulty data towards the end there as well. So this graph is from Activity 2.5. We were looking for the mathematical relationship between the average acceleration and the average force. And when we graphed it out, you can see that we have a nice straight line on our graph, which just gives us more evidence that the average force and the average acceleration are proportionally related. The objectives that we looked at for Experiment 4 were finding and understanding the relationship between the direction of the applied force to an object and the direction of the acceleration of that same object. We also wanted to understand that the combined forces are the sum of different forces acting together. It was also important to define combined forces, which change an object's motions, as stated in Newton's second law. And we wanted to understand the motion when no net force is applied to an object, and how Newton's first law describes that motion. In order to complete all the necessary activities for Experiment 4, we needed to use LagerPro, the proper experiment file, a force probe, motion detector, low friction cart, spring scale, smooth ramp, low friction pulley with string, a variety of hanging masses, and several fans. We did face some challenges in experiment 4. The first, I want to take a look at this table here when we were comparing the forces of just fan A, fan B, and then both of the fans together. For fan A, you notice we have a negative acceleration, so there might have been some interference with the motion detector while that was happening. There was also the lab where the carts needed to have the same direction of the airflow. And the first time we set up that lab for that activity, the airflow was actually going in the incorrect direction. So we had to redo that lab entirely and re-record our results to make sure that we were pushing our cart in the proper direction to get the results that we wanted. For activity 1.1 and activity 1.2, we can see the relationships between the velocity, acceleration, and force of the cart being pushed away from the motion detector on the top graph and then towards the motion detector on the bottom graph. As you can see, while the velocity and the acceleration varies, the force for both graphs remains about the same, no matter what direction that the cart is being pushed. We set up activity 3.1 by placing a cart in the middle of the ramp and placing one fan on each end of the cart so the airflow was going in opposite directions. When we turned on both of the fans at the same time, we got the data shown above for the velocity versus time graph and the acceleration versus time graph. Since the fans were working together, it was not accelerating. And we know from the previous experiments that acceleration is directly proportional to the force. So if the acceleration was 0, we can conclude that the net force acting on the cart must also be 0. The objectives for experiment 5 are to define mass in terms of an object's acceleration under the influence of a force, find a mathematical relationship between acceleration of an object and its mass when a constant force is applied, examine the mathematical relationship between force, mass, and acceleration in terms of SI units, and develop consistent statements of Newton's first and second law of motion for 1D motion for any number of 1D forces acting on an object. In order to complete all of the necessary activities for experiment 5, obviously we needed to use LagerPro with the correct file. We also needed a force probe, motion detector, low friction cart, a variety of masses so we could increase the mass of the cart, a spring scale, an equal arm balance, a smooth ramp, low friction pulley with string, and a variety of all of the hanging masses. So experiment 5 presented us with a lot of challenges. One of the main issues that we had was trying to balance the cart with the added masses, because we were supposed to, like multiply the cart mass by 1, 1.52, etc., all the way up until 3. When we were trying to use the spring scale, no matter how much mass we added on the opposite side, trying to balance out that with the cart, nothing moved, and we didn't get anything really to balance it out. So honestly, I think our spring scale might have been broken. Based upon us having the issues with the masses in the cart, trying to adjust it in the beginning, that could definitely be a source of error for our data. So for experiment 5, we're going to start with looking at table 1-1. We are looking at the mass of the cart in relation to the average applied force and the average acceleration. As you can see from our data, even as you increase the mass, it doesn't look like the force went up by very much at all. But we do know based on Newton's second law that if it's a bigger mass, you will need a bigger force for the object to move. So there could have been an issue, like I said previously, with us just using the mass scale incorrectly and having issues, which is why our data didn't turn up the way that you expect. If we want to take a look at the bottom, this shows the graph between the average acceleration and the mass as it increases. As you can see, the graph looks all over the place, probably for the same reason that we were having difficulty using the mass scale and getting everything balanced the way that it should be, which is why our data didn't agree with Newton's second law of the mass and force relationship. So if we take a look at activity 1.1 and extension 1.5, these activities were both performed the same way. We had the carts and the masses stacked on top of them, and then attached to that we had the string with the hanging mass that was being pulled by the hanging mass away from the motion detector. The only differences were that in activity 1.1, the hanging mass was a little bit less, and then at extension 1.5 we actually doubled the hanging mass because we wanted to double the force on the cart. And when we take a look, the graph at the bottom is extension 1.5, and when you compare that to the graph on the top for activity 1.1, the force has definitely increased. And if we want to take a look into the acceleration between activity 1.1 and extension 1.5, it does also look like as we increased the force in extension 1.5, the acceleration also did increase. So in conclusion, we've taken a look at labs 3, 4, and 5. We've gone over the necessary materials that we needed to complete all of the labs. We also did dive into how we set up certain activities. We went over all of the challenges that we faced during all of the labs. And we also took a look at some analysis and some details based on all of the experimental data that we had at the end of all of the labs.